Okay, today we're going to be talking about quadratic roots, quadratic roots, if you remember what we did a few weeks ago, we graphed parabolas. Parabolas look like that. We graphed quadratic equations, okay, in standard form. So what we're doing today is very similar to that. We're just adding something to it. So we're still graphing quadratic equations exactly like we did a couple weeks ago, but this time we're adding what we call our roots, which our quadratic roots are just the x-intercepts. That's basically it. So we're identifying the x-intercepts, and that's what we call our quadratic roots, or solutions, or zeros. It goes by many names, but it's basically those x-intercepts. And that's quadratic roots. Let's get started. All right, so quadratic roots, again, you have the definition there. You could read it yourself. I already mentioned it in the previous slide. Now, one thing I want you to write, though, is they're also called zeros, solutions, and x-intercepts. So you could hear any one of these. I could say find the quadratic roots. I could say find the zeros. I could say find the solutions. I could say find the x-intercepts. And that all stands for the same thing. Now, there are many different types of, or actually there are three types of solutions that you could get when you're talking about quadratic roots. One would be two solutions, and that's where the parabola crosses the x-axis in two locations. Now, if the vertex is right on the x-axis, then we have one solution. That's the second type of solution type. And there is a possibility that we have no solution if it doesn't cross the x-axis at all. Now remember, it's different from the y-axis, okay? Your parabola is always going to cross the y-axis at some point. But your solutions are where it crosses the x-axis, which is this horizontal axis here, okay? Those are your three types of solutions that you'll see when you do a quadratic root. Now, with quadratic roots, it's very important that you remember everything that we learned a few weeks ago with standard form of a quadratic equation. Remember, standard form of a quadratic equation is y equals ax squared plus bx plus c, okay? And to graph equations in standard form, you would need to use the axis of symmetry formula, which is x equals negative b over 2a. All right, so hopefully this is jogging some of your memories. Hopefully some of you remember this. If not, look back at your notes. All right, so the first thing you're going to do is identify your a's, your b's, and your c's. So a in this case is going to equal 1, b in this case is going to equal 4, and c in this case is going to equal negative 5. All right, then you will just plug that into the axis of symmetry formula, which is x equals, and it's going to be negative 4, because it's negative b, over 2 times 1. All right, and just a side note, remember that c value represents our y-intercept. Not really important for roots, but I just wanted to remind you what that c value represents. All right, we go ahead and keep solving this. Negative 4 over 2 would give us negative 2. Now, our next step would be to find the vertex. How do we find the vertex? We take the axis of symmetry and plug it in to the x values in the quadratic equation. So you do this you could do this in your calculator. It's y equals, this one's pretty simple where you might not need to do it in your calculator, but if you are putting in your calculator, make sure you put parentheses. All right, and if you go ahead and solve this, you get y equals negative 9. So your vertex is going to be negative 2, negative 9, and we put that value in the middle of our table. And then you know the rest. We number up and we number down. Now we're looking for x-intercepts. So if you remember our discussion on x-intercepts a few months ago, x-intercepts is when y equals 0. So if we have a 0 in this y column, we know that that's going to be one of our quadratic roots. We might have more than one. We could have 2 quadratic roots. Might have none. So let's just see if we have any zeros in that y column. Now, the rest is just calculator work, so plug all these numbers into your calculator or try to do them. These are pretty easy numbers, so you might be able to do them by hand. But if you do that, you should get 0, negative 5, negative 8. And then negative 8, negative 5, and 0. So before we even graph it, it looks like we are going to have 2 solutions, or 2 quadratic roots, or 2 zeros. Okay? But let's just go ahead and graph it for fun. Negative 5, 0. It's going to be right here. Negative 4, negative 5. It's going to be right here. Negative 3, negative 8. It's going to be right here. Negative 2, negative 9 is here. Negative 1, negative 8, 0, negative 5, and 1, 0. And you can see that this graph crosses the x-axis at 2 points. This graph that was even worse. This graph crosses the x-axis at 2 points. There are 2 quadratic roots. Now let's go ahead and label and identify our quadratic roots. So our solutions are going to be, now there are 2 ways of writing this. You could just write the ordered pairs, which would be -5, 0, and 1, 0. All right, or you could just put the x-intercepts are -5 and 1. Whatever way you prefer. But we have 2 solutions, 2 quadratic roots. Let's do another one. All right, so number 5. This one's also going to give us 2 solutions. I was hoping to give you some with 1 or no solutions, but we'll do some examples with 1 or no solutions tomorrow. So if it looks like this, well, let me change the color. If it looks like this, right, except not that deformed. Let me try again. If it looks like this, then that's going to be no solution. If it looks like this, that's going to be 1 solution. We're going to do a few examples that look like that tomorrow, but this one's also going to give us 2 solutions. That's fine. There's another reason why I wanted to do this one, and I wanted to remind you of what the b value is in number 5. So if we look at number 5, a is going to equal -1. Now b is not going to be 9. Remember, it's ax squared plus bx plus c. So the number in the b position is 0 because there is no x. And then c is going to be that constant, that 9. So your axis symmetry formula, x equals -b, which is just 0 over 2 times -1. Well, that's just going to be 0. So your axis symmetry is going to be 0. To find the vertex, you just plug in 0. So it's going to be -0 squared plus 9, which is just 9. Then you number up and down, -1, -2, -3, then 1, 2, and 3. And then put this in your calculator. So we're going to have 0, 5, these are pretty easy where you might not need to put it in your calculator, but and then 8, 5, and 0. All right, so it looks like, again, we have 2 solutions, -3, 0, 3, 0. Let's just graph it on the coordinate plane here, -3, 0, -2, 5. -1, 8, 0, 9, 1, 8, 2, 5, and 3, 0. And you can see that it has 2 solutions. There you go. Now let's talk about the discriminant. So the discriminant is used to determine the number of solutions. So it's used to determine the number of solutions without creating a table, without graphing. All right. And the formula for the discriminant is b squared minus 4ac. Now, if your discriminant is greater than 0, then that means that there are going to be 2 solutions. If your discriminant is exactly 0, equal to 0, that means there's only going to be 1 solution. That means the vertex is going to be the x-intercept. And if the discriminant is a negative number, if it's less than 0, that means there are 0 solutions. And this is the formula. Make sure you copy this down, copy that formula down. All right, so let's identify the amount of solutions without graphing, without creating a table, by finding the discriminant. All right, so remember the formula for the discriminant is d equals b squared minus 4ac. So in this case, A is going to be 1, B is going to be 5, and C is going to be 4. So you just plug it in. It's going to be D equals 5 squared minus 4 times 1 and times 4, which is going to be 25 minus 16, which equals positive 9. So because it's a positive 9, that means it's greater than 0, okay? That means there are 2 solutions. And we did that without graphing, without creating a table. All right, number 9. So here we have an A, which is a 1, a B, which is 10, and a C, which is 25. So just plug it in. D equals 10 squared minus 4 times 1 times 25. All right, so that's going to equal 100 minus 100, which is 0. Now, if it equals 0, that means we have one solution there. So there's one solution for that problem. And then one more we're going to do. A is going to be equal to 4. B is going to be equal to negative 12. C is going to be equal to 9. Remember, the formula is D equals B squared minus 4AC. So there's going to be D equals negative 12 squared minus 4 times 9. Negative 12 squared is 144, and that is minus 144. So 144 minus 144 is 0, which means that we are going to have one solution. That's the discriminant. All right. Tomorrow we'll do some more quadratic roots and zeros with graphing, and we'll work more on discriminant. But just make sure you have all these notes, and I will see you tomorrow. Have a great day.